Hello and welcome to the Data Engineering Podcast, the show about modern data management. Schema changes, missing data, and volume anomalies caused by your data sources can happen without any advanced notice if you lack visibility into your data in motion. That leaves DataOps reactive to data quality issues and can make your consumers lose confidence in your data. By connecting to your pipeline orchestrator like Apache Airflow and centralizing your end-to-end metadata, DataBand lets you identify data quality issues and their root causes from a single dashboard. With DataBand, you'll know whether the data moving from your sources to your warehouse will be available, accurate, and usable when it arrives. Go to dataengineeringpodcast.com/databand today to sign up for a free 30-day trial and to take control of your data quality. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's Linode, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Saket Saurabh and Avinash Shahdadpuri about Nexla, a platform for powering data operations and sharing within and across business boundaries. So, Saket, can you start by introducing yourself?
Hi, this is Saket. I'm co-founder, CEO at Nexla. I'm an engineer by background who eventually went towards the business side, and I've been in the world of data for almost 12 years now.
And how about you, Avinash?
Hi, I'm Avinash, founder CTO here at Nexla. Prior to this, I worked with Saket on his previous startup, which was in the mobile ad tech space. And before that, spent a bunch of years building data systems in financial services, so risk management platforms, and trading systems, etc. Great to be here.
And going back to you, Saket, do you remember how you first got involved in data management?
Yeah, absolutely. So as I said, I was an engineer by background through several companies. But then in 2009, I started a company for, building a mobile ad server, one of the early ones at the time. In that company, which was called Mobsmith, we ended up building a pretty complex data system. As you know, Tobias, there's a lot of data in the advertising space. That's why you've seen Google, Facebook, and these companies build a lot of data technology, right? We ended up building a system that would process nearly 300 billion records of data every day. We're doing some very sophisticated machine learning on that for pricing, ad auctions, and so on. Ended up creating a huge data platform as part of this advertising startup that I was doing. That's what got us into the data space. Yeah.
And Avinash, how about you?
I was building risk management and trading systems on Wall Street. We found this ad tech company. We were very early users of most of current state of our technologies. So very early users of Kafka, very early users of Spark. And then we saw this problem from very close quarters that every time a non-engineer came to us with a requirement, we were like, oh, we need to put this to the back of the queue. And it will take us a few months to do this. This is where we thought about how about we build something which makes it easy enough for a non-engineer to build a data solutions with sort of the rigor of an engineering system.
In terms of the Nexla platform, you mentioned that it's aiming to help reduce some of that time delay and backlog in terms of being able to incorporate new requests and new data sets. And I'm wondering if you can just give a bit of an overview about what it is that you've built there and some of the story behind how you got it started and why you've decided that this is the problem that you want to focus on right now.
So, as I said, there's a lot of data in advertising. For Avinash and me, for both of us, as well as our other co-founders, we felt that the data challenge that we worked on advertising was super interesting. We were not as enamored by the advertising and the media side of our business, right? And I had come into this world of data through the way of the compute side of the world through having worked at NVIDIA. And when we came together and we're looking at this at our last company, we felt like, look, there's a lot of data in here. We end up getting data from hundreds of different partners and companies, and clearly we have gotten a lot of value applying that towards machine learning. So the thinking that took us towards Nexla was that this is a problem, and this is back in 2014 for setting context, right? So this is in 2014, we're thinking, well, we think more and more companies will use data in more efficient ways, but it will be really hard for them. There's a lot of technology that has to go in, and that started to seed the idea of Nexla inside of us, which is, hey, companies will have data in their organization. They will have data that they will get from their ecosystem. It'll be hard to work with. More and more people need to work with data, however. So how do we make that happen? How do we take all this complexity and growing complexity of data, and how do we make it possible for someone who is not an engineer to be eventually able to work with it and say, this is what I want to do with my data? And that was the core behind starting Nexla.
In terms of the sort of overall problem space that you're tackling, you mentioned that one of the problems is being able to allow non-engineers to access and ask questions of the data that exists within the organization. And I'm wondering how you are approaching that problem, some of the scope of the problem that you're taking on at Nexla, and some of the ways that Nexla might integrate into an existing data platform.
Sure. So when we pose the question, how can data be used by more people and in more applications, then it led us to 4 core problems that we felt had to be solved. Okay. First, and as I said, we wanted the non-technical user to be able to do this. So that led us to 4 key problems. First was that we had to break through this connector barrier. And there's so many systems to connect to, so many formats, different velocities of data. How can we connect to new data systems without having to go and write and create new connectors? So that led to a piece of our technology which we call as a universal connector. We can talk more about that. So that was one problem. The other problem was that once we can connect to the data, how do we present to the user in a way that they can understand? And that led to the concept of Nexsets as a logical data unit, something that is consistent no matter where the data comes from, right? Then the other problem that we also looked at, as I mentioned, we were also thinking about data that's going between companies and their ecosystem of their customers, their partners, their vendors, and so on. So we thought that if data has to move across companies, it will have to move across clouds, it will have to move across on-prem to cloud, and therefore the architecture should be such that it can support those scenarios, right? And then the fourth thing, we felt that, we want the data user, the person who understands the data, to be empowered, but data challenges are very diverse. So we will need to have a way to collaborate. So one of the other problems was collaboration. Collaboration all the way from someone who is an expert in the data to someone who is an expert in the data system. And then, and that led to the concept of no-code capabilities in Nexla, to the low-code capabilities, and the full-on developer platform, which has APIs and SDK and CLIs and everything.
As far as somebody who has an existing data platform and they're looking to be able to simplify some of their data operations and take advantage of what you're building at Nexla, what are some of the components of a sort of common data stack that somebody might replace with Nexla? So I'm thinking in terms of maybe like the open source components that people are familiar with, such as Spark or Kafka or the data warehouse, or just sort of where Nexla sits in that overall domain.
At a very high level, I would say when it comes to technologies like Kafka, Spark, and so on, we don't replace them. We actually make them more usable by people, more easily adopted. There's sort of 4 things that we solve for companies, right? One is the integration aspect, which is multimodal integration with ELT integration, ETL, reverse ETL, streaming integration, API integration. So we look at all these 4 modes of integration, and we present a solution for that, something that can be done in a user interface, click through, and so on. When the actual execution happens, we leverage, or we are able to leverage some of these technologies as appropriate, like Kafka or Spark or some of our homegrown engines as well. So in that way, we can sit on top of or benefit from the tech you already have or the know-how you have, but make it more accessible to more users. By the way, I would note that we never think of it as a replacement. Whenever it comes to technology, especially in data, there's so many problems that are coming that are new. That's not usually go back and rip and replace things. It's more about solving the new problems, right? So integration is one part. The other part is the preparation of data. How do we transform, enrich, filter, validate the data so that it becomes ready to use? Integration means just reading or writing it. So preparation is the next part of that. Since we are in the flow of data, we do enable error management, data quarantine, notifications, alerting as far as the flow of data is concerned and what we expect from that. And then, the fourth piece that we touch in addition to integration, preparation, and monitoring is the discovery. We sort of auto-generate a catalog from our Nexsets that we'll talk about where users can find, hey, where's the data I'm looking for? Is this the right one? And then, access and use it.
And a point to add here is these are all pluggable components. So it's not that you want to use the entire thing. You can sort of choose to use a part of this. For example, if you already have written some code in Python, but you don't have the integration layer to where you want to fetch this data from, or you have a new integration layer that you want to fetch data from, you could use Nexla for the integration piece, but you could use your pre-written transformations in Python to transform your data and then push it out. Similarly, if you have a new customer requirement who wants to move from GCP to Azure, you have all the logic that you want on GCP, but you don't have a Synapse connector. You could probably use Nexla to just push data to Synapse, again, which is you use your existing thing, but you're able to get the additive thing from Nexla in a matter of 2 or 3 clicks.
So we have very much been used with existing monitoring systems, with existing catalog systems where we end up supplementing them or feeding information into those tools and make them more capable.
In terms of the Nexsets that you mentioned, one of the use cases that is highlighted in your website is the ability to publish those Nexsets for creating a data exchange between businesses, which is something that I've seen spoken about a few different places. It doesn't seem to be as widespread as one might think, largely because companies are using their data assets as part of their competitive advantage, and so they try to keep them proprietary. And so I'm wondering what you see as some of the use cases for those data exchanges and some of the ways that you are approaching that challenge of mitigating the decrease in competitive advantage that businesses might have by exposing their data, and some of the types of data sets that organizations are more willing to be able to either make public or engage with directly with other organizations to be able to share between them.
First, a quick definition, for Nexsets for those who are listening to this is that Nexsets are these logical data units. They don't have data, but they become a way to access and use data. And so these Nexsets have the concept of sharing and collaboration built into them. This happens within the team, of course. I can create or design an Nexset, which is PII compliant data, and give access to a team to use that. But this has great applications, as you said, Tobias, across companies. Where do we see that? When two companies work together, as you can imagine, there is always some flow of data going between them, right? We see this with some of our customers. For example, one of our customers is Instacart. For them to deliver groceries, they will need to know that, hey, does this, Safeway or Albertsons or whatever, do they have the products available? And can I go pick it up? Can I list it, right? So there's clearly data that Instacart is using that's coming from that, merchant partner of theirs, right? So there are these cases where we work and, we enable that sort of flow of data across the companies. That's one part of that. The second part of it is a community aspect. We've seen people like, hey, I've worked on this healthcare data, which was publicly available. I've integrated with it. I've massaged it. It's ready to use. And now I can share it. I can make it public and anybody can use that. So there's that part of it as well. And then there is a flexibility part to it, right? It's not unusual for companies to put files on FTP or create an API so that they can give data to somebody else. What happens though is that there's a two-way integration challenge. You have to generate that data into a file and push it to an FTP server or create an API. And the other party now has to integrate to that. They have to, fetch that data and run a process for it. So these Nexsets are enabling this where once you give somebody access, you give them the choice. Do you want to consume that data into a file, into an API, into a database, and not have to integrate at all, just a direct sort of pipe in that way? So there is a lot of power in that. We do see that these use cases are growing, and there's some real benefits for the companies and their customers.
Yeah, as soon as you started to discuss the data sharing aspect, I was going to bring up FTP. So thank you for beating me to the point on that.
It's been there for 30, 40, 50 years, and it's going strong, right? And yeah.
I just filled a form for an integration request, which said, do you want to put it on our FTP server or should we pull it from your FTP server? So it's as recent as yesterday. But to the other point, I think the aspect of how companies share data, they probably give you a username, password, and then you forget about it. How do you know what all integrations are currently connected to an FTP server and API, it's very hard with today's systems. You sort of go and look at your FTP server logs. When did these users last log in? Or you look at your deep inside API logs. What are the users connected currently? But with a system like Nexset, you can just go to a screen and see these are the things that have access to when was the data last pulled. So the monitoring aspect of data exchange is also something that I think prevents companies from connecting multiple different data systems, because you are scared of how will I know who is using my data? So having that aspect is also useful.
I've seen horror stories of, somebody changed a column name between, an insurance company and an automotive company or whatever, and the whole thing came down because of that, right? So, yeah, it's a big problem sometimes.
And so the more modern analog to the FTP server is the capabilities that systems like BigQuery or Snowflake offer with being able to share either tables or data sets from your data warehouse. And so I'm wondering if you can give a bit of a comparison to what you're building with the Nexsets and some of the capabilities that they provide over and above those systems.
Yeah, I think the shared tables in these systems like BigQuery and Snowflake are a great way to share data. What the Nexsets are helping companies do is one, bring the data into that BigQuery, into Snowflake. Sometimes it's not already there. That's definitely a value add. But the other thing we have to note, which is even more important, is that once the data is in a warehouse, you have become a batch or a static system. So in use cases where the data needs to be going kind of real time from one system to another, then these Nexsets, as I said, have multiple sort of execution engines underneath, can continue to move the data in real time. And there are many use cases. We see, e-commerce shipment tracking, as one example where the data needs to be, real time.
When you share a table from Snowflake or BigQuery, you still need to do a lift and shift on where do you want to eventually use it. So you might use it in a machine learning algorithm, but again, you need to extract the table, push it out there, build a process around it, and all of those things. With Nexsets, you're solving the problems at both ends of the ecosystem. On one side, you can have a Nexset, which can push data into these things. On the other side, you can have a Nexset, which can be referenced in a machine learning model. So you're solving both of those things, but yes, these things do coexist. So we have customers who would share a table in Snowflake, but then we'll have another customer who would just consume the data of that from that table with a Nexset on top of it.
I've had actually cases of companies come to me and say that, hey, we are not, say, current customer of X or Y data sharing tool, but our customers are asking us to bring the data there. Can you give us a mechanism to move the data from, our database, our lake, or wherever into that system so we can share? So yeah, there's definitely an integration need in some of these cases.
All of this capability of being able to deliver the data from one system to the other or to do the integration is being covered by the term DataOps or data operations that's gaining ground. And that's one of the keywords that you're targeting in terms of the positioning of what you're building at Nexla. And so I'm wondering if you can give your version of what DataOps involves and some of the elements that need to be implemented to be able to actually deliver on that promise.
We were one of the early ones in 2016, 2017 talking about data ops. Our thinking about operations was that, the purpose of operations is to bring scale. Not in terms of data volume necessarily, but in terms of, how things are run. How are more people working with data? How are there more data sets in more applications? So we took that sort of point of view of operations when using the word operations along with data. So our approach to the operations aspect was that you have to have certain degree of automation, right? In how you connect with data, how you flow data, how multiple people use it together. That's how you'll scale your team, right? So those were the sort of core principles that we started with on the data operations side. The resulting application for the user was that, I need to integrate data, I need to prepare it, I need to monitor that. So we think of the operations as a layer on top of these fundamental data functions, right? That allows a team to scale.
In terms of the actual architectural and implementation details of Nexla and some of the ways that you're able to build these Nexsets, I'm wondering if you can give an overview of some of the technical aspects.
So the fundamental premise behind Nexla was, on one hand, you have a lot of variety of data, increasing complexity. On the other hand, you have a user who shouldn't have to write code, right? So we figured that in between, there has to be tech that can take all that variety of data, different systems, connectors, and so on, and present the data to the user in a useful fashion. And that was the Nexset, right? So these Nexsets, the way they start functioning is, first of all, they start with observing the data. So the connector is spitting the data out, and the next sets, that element is observing the data and it's figuring what is the schema, and it will get a schema from, the first set of records, but it'll continuously keep looking at it. So the first aspect is, what's the schema of the data? Infer that, observe that over time, determine if the schema is changing, evolving, or the data that is coming now is actually should be a new next set. So that's one aspect of the thing. The second aspect of the thing then is like, what time does data come? How much data do we see? Those are some of the metadata that we observe about that as well. Then when we go into the data itself, we say, oh, the data has an attribute called price, and it has been changing like this. So we're computing characteristics of the data, right? So these are some of the elements that come in. The sort of going term for that is metadata intelligence. And, people are calling it as a data fabric architecture, but, those are all the terminologies. Let's stay on the tech itself. So that's what happens. And that sort of feeds into the concept of the Nexset, right? Now, the Nexset also knows where the data is coming from. So for example, this record was line 500 in that file, for example, right? So that information is also being gathered. Right? And then it starts to say, okay, I know enough about the data to present it to the user in a UI that they can look at. But at this time, it doesn't matter to the Nexset that the data came from a stream, or it came from an API, or it came from a file. It's immaterial where it came from. It can be presented to the user in a common interface. And then the Nexset over top of that say, well, who can access it? What is the history? How has the schema changed over time? Which user has modified it? And then along with that, they keep documentation, right? Hey, what's the description of this Nexset? Has the user created an annotation for an attribute to say, oh, this attribute is actually coming from a web form? So those are the other things that come in and become part of the Nexset. And then as the data is flowing through, the Nexsets are not doing anything. They're like an incomplete electronic circuit, right? So it's not flowing anything yet. It's observing, it's sampling, but nothing is flowing. Once you connect the Nexset to a data system, right, then it starts to materialize the data there. So you point an Nexset to a database and it says, okay, it's going to be an ETL flow, let's say. Or if you want to get an API to the data, it can surface that, or wherever you want to use the data, it can now materialize. But it knows enough about the data to now convert the format, for example. It also knows enough about the data to now run some validations on it, right? Or this field should have been like this. Or let the user define their validations. And then when it sees those validations fail, then it throws the data record into a quarantine area where it's a separate sort of processing that you can do. So the Nexset sits as this logical entity in the middle, and then sort of acts as like the data router when you eventually end up using.
And then there's a complexity on the whole runtime aspect of this, right? How do you run a Nexset which might have trillions of records behind it, and also run a Nexset which might have few hundred records on the same system? How do you separate out your execution engines from a user who is waiting on the other side to receive a response within 100 milliseconds versus user who is expecting a batch of data to be dropped in his data warehouse once in the night, right? So that itself is challenging. And you present the same interface to the user, but under the hood, you can have different execution engines running in parallel.
Yeah, but that's the execution part of it. And at the next level, you're just looking at it in the UI, you are making your decisions, you're designing stuff. And when it's done, then the execution knows like from all that information like what to do and which execution engine is right and all that stuff.
And so in terms of the actual technical details of executing on the plans that the Nexset generates, is that something that you're performing on behalf of the end user, where you have your own infrastructure and data platform architecture for being able to do all this processing? Or is this something where you provide the sort of orchestration and implementation layer, and then the customer has the actual underlying infrastructure that just executes on the plan that you generate for them?
So for the execution part, which is kind of the data backplane, if you will, the processing stuff, That is something that we provide as a SaaS hosted service, but we run multiple instances. There's an instance in Amazon, there's an instance in GCP, an instance in Europe. So depending on what you need with the data and where it needs to be processed, we provide that execution engine, which is all the scale up and scale down of the containers, the underlying, Kafka, Spark, real-time engines, whatever it needs. It's all packaged and included. But we also do allow our customers to run Nexla on their own. So, they may need this for high-value data on-premise, and that's not connected to the internet. So they can run this whole thing internally. So they can choose to run their own data backplane, and we provide them with, the necessary Terraform templates or, to execute and run that. The end execution is sort of distributed in a federated fashion.
Given the level of flexibility that you're targeting and the level of sophistication that you're trying to offer and be able to abstract away some of the technical complexities that underlie it, I'm wondering what are some of the engineering challenges that have been most challenging and that have been most critical to your continued success?
There have been a lot of engineering challenges. I'll add a few. I'm sure Avinash has many, many more. And it's never ending, by the way. You solve a challenge, you get more. The first challenge, we felt like, hey, if you're working with data coming from outside the company, we don't know what the API format, schema will all be. So the first challenge on the engineering side was connectors. How do we end up in a place where we are not creating new connectors? We don't want our customers to wait for us to write a connector. That was one engineering challenge. We ended up creating an abstraction layer so that we have 4 main connectors and with bunch of bells and whistles, but everything like authentication and retries and probing a connector, managing credentials, all of those layers are abstracted on top of that. So that was one sort of part that was a big engineering challenge. This multimodal data processing that Avinash mentioned is another engineering challenge, right? So you think of Nexla, let's say you have a database as a source and you're reading data from it and you're pushing the data into an API, right? In a normal flow, it will probably run in Kafka. If you reverse the flow, if you call the Nexset and say, hey, give me the data, as an API call. So you make the API call and you're waiting for the data to come back in say 10, 15 milliseconds. That doesn't go on Kafka. That's a real-time engine, right? So in this exact same flow that you had designed in Nexla, you can access in 2 different ways and it will run in 2 different ways. So having that sort of multimodal data processing engine, and we recently started to offer bring your own data engine. If you have created some mechanism of processing data, you can bring it in and we give you the interface to run that. So that's another engineering challenge. And I think the third one, which is my favorite, is, the whole infrastructure is very dynamically orchestrated. It's all, container-based architecture, but these containers come up at the right time to read the data, process it, go away, and all that stuff. And the reason it's my favorite is, by the way, when we started building Nexla, for the first 6 months, I was like, when can I run the first data flow? And they're like, no, we're building the orchestration. And we did invest a lot of effort in building that orchestration piece.
You want to simplify the view for an end user, but then there is a lot of things that happen at the back of the system to make it simple. So Saket talked about this dynamic orchestration. You can do this dynamic orchestration in like 4 different systems. Everybody talks about Kubernetes now, but the land of Docker, Kubernetes, Mesos, all of these things have evolved over a period of time. You might want to run this in a managed service. You might want to run a few things within a warehouse, for example, because it's best suited. How do you make that switch with a simple interface on the top is super challenging. At the same time, users have done sort of fantastic things with net sets. We have some users who have pointed PDF files and gotten a net set out of it. This is something that we were not originally thinking about, but people have done that by using sort of an OCR in between. So yeah, what we started with was clearly a simple concept of what we can do with net sets, but with these fundamental building blocks, people have sort of used our platform as different Lego blocks and built things that we didn't imagine in the first place.
We've all been asked to help with an ad hoc request for data by the sales and marketing team. Then it becomes a critical report that they need updated every week or every day. Then what do? Send a CSV via email? Write some Python scripts to automate it? But what about incremental sync, API quotas, error handling, and all of the other details that eat up your time? Today, there is a better way. With Census, just write SQL or plug in your DBT models and start syncing your cloud warehouse to SaaS applications like Salesforce, Marketo, HubSpot, and many more. Go to dataengineeringpodcast.com/census today to get a free 14-day trial. In terms of that multimodal execution engine, the first thing that comes to mind is being able to ensure consistency in the processing between those different modes of operation, where in this batch situation, I want to be able to ensure that I'm doing the transformations in the same way that I might be doing if I'm doing it in a streaming situation, which is sort of the canonical problem of, the Lambda architecture or the Kappa architecture, this division of batch versus streaming. But then there's also the question of real time that you mentioned of, I want to be able to hit this API call and have it give me the records from the database at the time that I request it without having to wait for it to propagate through Kafka or deal with change data capture to be able to replicate that information. And so I'm wondering how you're approaching that complexity of being able to ensure the consistency of logic in these different ways of executing and on these different substrates.
I'll add one quick note on that, and I think Avinash can give you a lot of the gory details. But there's a key part that the processing of the data happens in exactly the same code base that actually runs in multiple places. That module can run, in a Kafka stream. That module can run, in your Spark. That module is run, by our servers as a microservice, right? So that gives us the consistency that there's only one place. We're not trying to replicate the logic in multiple different systems. That's extremely hard to achieve.
Yeah, that's the fundamental reason, because when a user is coming to Nexla and then creating netsets, or Nexla is auto-deriving netsets, we are able to keep what makes the netset totally separate from where the netset gets executed. And this separation of concerns between definition of netset and execution of netset is what gives it this power of being able to run in different places. So, tomorrow, if there is a new flashy execution engine that comes, we should be able to take the same net set and bridge the gap with that execution engine without really changing anything on the net set itself.
As a user, you've told us, here is where my data sits. This is what I want to do with it. This is where I want to use it, right? How you execute that, does depend on a few things, like I want it real time, I want this or that, but it shouldn't matter to the user, and, it stays agnostic.
And then in terms of the ideas that you had going into this business and this problem space of, this is how I'm going to approach the problem, these are the technical aspects that I'm going to have to cover, this is how the sort of overall workflow and end user experience is going to look. What are some of the ways that initial design and architecture has changed or evolved, and what were some of the early assumptions that you had going into this that have been either challenged or invalidated as you have built out the platform?
I think when we started, we thought that streaming would be the be all and end all. It will stream, it will be micro batching and do all of that. We did come across real-time use cases pretty early on, and then we also came across use cases where streaming could be an overhead that was not necessary to bear. So I would say that we started from that streaming engine core, and then we became multimodal engine over time. Our abstractions helped us get there, but that was definitely a big change of assumption. We always thought of data as who is producing the data, who's using the data. And I think that concept has also evolved quite a bit within our product, just giving more flexibility and not just thinking about the source and destination, but thinking about the next set as like, hey, that's an entity that you can use, and you choose how you want to use it. Or things like, hey, if I have a next set, then can I find it? Does it serve like a search purpose? So, that piece also evolved quite a bit when our initial thought was more on sources and destinations.
And one other thing that has is having a platform which is pluggable at different places has huge benefits. So the way we thought about some of these things was, what are the points where we want the platform to be open? Can somebody use the underlying Nexla infrastructure, bring their own connector? Can somebody bring in their own transformation logic? Can somebody bring in their own validation logic? All of these things, when we started thinking about this, we're like, oh, let's try to open up these points. But what has happened is, over a period of time, the points where we have opened this via our APIs, via our command line interface, has made the platform more and more powerful.
Yeah, actually, we started with the inspiration from set of Excel. There are a lot of built-in functions that anybody can use, but advanced users can create macros and add their own custom menus. So we thought that no code and low code would be a great combination, will solve everything. But eventually, what happened was we ended up opening up all our APIs. We ended up creating a command line interface, which we had never thought we'll do in the early days. But our own ops team said, oh, hey, we want a command line interface. And then we opened it up to our customers. So there's definitely things that came along. And I think that's what makes the data space exciting, to be honest, right? I mean, you think you have done some amazing work, and then up comes a new challenge the next day because a customer asked you for something and you're like, yeah, you're right, we should have that, or it makes sense, and then you're on to the next one. So yeah.
Going to the sort of automated integration and some of the abilities that you're exposing through these Nexsets for being able to say, this is my source data set, this is how I want it to end up, and then being able to generate the transformations or generate the logic that so that the user doesn't have to handle that. That's where a lot of the challenge comes in for data practitioners is I have this source data, I need to be able to transform it in such a way that I'm either not introducing my own sort of bias or my own interpretation of this information, or I'm not going to create a lossy transformation that prevents me from being able to actually answer the question that I was aiming for. And so I'm wondering what you have found to be some of the useful heuristics for being able to interrogate the source system to say, what is the data? How is it stored? What is the schema? How am I going to be able to actually generate these transformations to answer the question that the end user is asking for, or present the data in the way that they're looking to send it on to another system? And just some of the ways to be able to actually encapsulate and hide some of that complexity from the end user.
Actually, in that point, we actually again go back to the fact that within an organization, there'll be people of different skill levels, right? So, when we think of our connector, there's a very advanced mode where you can configure many, many things into it and literally connect to anything. But that converts into a template, right? So if I have configured that, hey, this API is OAuth 2 and it is three-legged OAuth and it has a pagination of this style, and if you call this API and pass its data to that API, then you will get this result. If I have, put all of that and configure that in Nexla, that can become something that's pre-packaged for the next person. They can just come and click on a button and go with it. So from a heuristic, I think more of it also comes from just like, how will people work together, right? And how will the person who knows a problem solve it once, but then it becomes a solution forever, right? At some point we'll make this community capable as well, where you can share what you have discovered or built in the broader community. So that's a big part of the heuristic that comes in. From a very technical perspective, I think there are definitely things that we have seen, as far as like schema management and stuff, like what can you do, when you start seeing more data, you see slight changes in the structure or the column, the attributes, and stuff like that, and how we've done like even simple unions of schemas can give you some very interesting results. Of course, we do more advanced match of schemas and overlaps and stuff, but some simple heuristics can go a long way.
And then another interesting aspect of these logical units of data that you're building with the Nexsets is the idea of being able to compose them together or do further refinements of an existing data set. And I'm wondering how that plays out in terms of being able to say, I've got this Nexset over here where I'm pulling data from a Postgres database and presenting it as a Parquet file in S3, and I've got this other one where I'm pulling data from a Kafka stream and I'm presenting it as an API, and I now want to take those two and I want to put them together and get a new Nexset out of that.
There are a couple of very interesting concepts there. The core concept is that a Nexset plus code or logic creates a new Nexset. So you take a Nexset, you transform it, the outcome is a new Nexset. You could give somebody access to that. Then they could do their own transformations, filters, enrichments, whatever, and get a new one and a new one and a new one. So that's kind of one sort of aspect, which is a linear. The second aspect is like, okay, combine 2 or 3 Nexsets together. We see this all the time with some of our customers. Take the product Nexset, take the inventory Nexset, take the price Nexset by store, combine that all into a single entry. There is a concept of looking up from one Nexset to another, just like in Excel, you have like a VLOOKUP, for example. You can do a lookups across Nexset. You can look into that. We have the underlying mechanics to hey, if the data is a stream, then appropriately cache it so you can do very fast lookups on that. We'll soon be introducing this concept of like even SQL joins and stuff like that on that. So there will be more things coming, but yes, it does make it possible for someone to say that in order to get the outcome that I'm looking for, I can create more derivatives or at any stage pass on to somebody else who might be the right person to do it.
And I think this is fundamentally possible because of having an open entity which is composable, right? So as you said, if you get data from Postgres and you get data from S3, currently, if you have to do it, you'll end up writing a lot of integration code and exposing something on top of this. But when you do this with Nexla, you're able to get two net sets, join those two net sets, and you have like 7 different ways of accessing that net set out of the box.
We had a very interesting use case. There was a freight broker that was getting emails from drivers, and that email would have an attachment of their driver license or insurance policy, and their goal was, hey, can we validate this driver and onboard them onto the platform, right? So they made these emails as sources in our system, and the first Nexset that would detect with the email would have the attachment pointing to that, and then it would detect some tables inside the email if they have that and stuff like that, right? That Nexset then was enriched by making calls to some, OCR systems and say, okay, from that image, what other information can we grab? So the resulting Nexset after that sort of processing or the enrichment stage with some external services had a lot more data from those documents. And then they had the logic to say, oh, is the driver license valid? Is the insurance policy large enough, or whatever they had the criteria? And then the outcome of that Nexset was piped is an API into their system. So they were able to say, okay, for now we are able to onboard like 80+% of the drivers automatically. And then where you didn't make that confidence score from the result, they could pipe the outcome of that Nexset out into a spreadsheet that ends up in the desk of an ops person who will manually approve or disapprove, right? So we find people come up with some extremely compelling and interesting applications by composing these Nexets together along with other third-party applications or systems they have.
And then for the situation where you might have two different Nexsets and you only want sort of half of the information that each of them are presenting so that you can combine that in a different way for a third Nexset, do you have a way of being able to sort of optimize the execution so that you don't have to run both source Nexsets to their completion and then take that output as input to the third one, where you can say, okay, well, I see that I'm pulling data from Postgres and S3 for this Nexset over here, and over here I'm pulling data from Kafka and an API, but I actually only want the data from S3 and the API, so I'm only going to make those calls for this third Nexset when people request it.
So the execution plan of the Nexset is tweakable. So you can say, I want this Nexset to run in A execution engine. I want to run another Nexset in B execution engine. There is a windowing concept that you can apply on top of a stream, for example, in this case, and be able to get a Nexset almost immediately out, right? So from a perspective of the underlying streaming and the real-time architecture, you are able to do things like these fairly easily.
I would say that, some of these use cases that you mentioned, sometimes you also recommend to people that, hey, it may be okay to materialize an Nexset into some system, then use it, and then make that as a source, and again, make a new Nexset. So I'll give an example, right? You get data from 3 different systems, and you're trying to do something complex, and you're like, you don't want to force fit a solution, right? So you can say, okay, these 3 Nexets, I'm going to materialize, say, in a database, right? Or data, and then I'll do some, ELT sort of transforms in there or whatever, and then make that outcome a Nexset and then take it further downstream. So sometimes problem solving in computer science and software is always like you can solve the problem in 5 different ways. One of the ways, as Avinash is saying, and I'm like, maybe that will be too complicated for a user to figure out. And sometimes you can break it down into a few linear steps and do that. So yeah, there's never one right answer in some of these use cases.
Yes, the correct answer in computer science is always, it depends.
Depends, yeah. People ask me, it's like, oh, is this the modern data stack? I'm like, no, there's no one solution that fits. Yes, you can do ELT and it makes a lot of sense, but no, it's not an answer for everything. I remember the question people used to ask, like, hey, is Java the programming language that will be there? And then everything else will be gone. And of course, over time, like, no, more programming languages will come and it depends. It depends what problem you're solving. So I would say the same thing with data solutions as well.
The capabilities and the opportunity for Nexla is definitely very impressive, and you are being very ambitious in terms of the types of problems that you're trying to solve and how you're trying to make this overall space of data complexity more palatable and easy to consume. And I'm wondering, what are some of the sort of grand hopes and ambitions that you have for the Nexla platform and some of the potential that it presents to organizations and for being able to build these data exchanges that are sort of more flexible and composable?
Yeah, I mean, at a very, very base level, our goal was always to present sort of multiple possible frameworks that people can use to build these data solutions. That was one part of it. The second part of it was like, how can you go from an idea to something working very quickly? I have seen large companies can spend months or years figuring out the framework and never get to an outcome. So it's always about like, how can you get to that faster, get the data ready to use in the system where you want to do that, right? So our big hope in general is that by taking a little bit of an approach where we step back and we said, hey, it makes sense to have certain abstractions in the data flow, and those abstractions can apply in multiple places. We think that one will make the life easier for many users, right? You don't want one system to discover the data, then have another system to integrate it, then have a third system to prepare it, then have a fourth system to monitor it, then have a fifth system to catalog it. I mean, the people have done that and it becomes extremely hard. So we're like, what's a good baseline that can cover and solve a set of problems for people, but then an open design so they can plug in their favorite tools and pieces in different places. So again, we go back to that sort of approach. It's a framework and present it to the people who are using it. And yeah, we do hope that this does become or introduce a collaborative way of working with data where people of different skill levels are using it, because I can see the future in my kids who are already learning to code at age 11 and looking at data in ways, and the future is everybody's working with data, and that's only possible if we build better, robust, more usable data systems.
And in terms of the ways that you've seen the Nexla platform used and some of the Nexsets that have been created, what are some of the most interesting or innovative or unexpected applications of the technology that you've seen?
Using that email attachment is a very interesting one. We had a large financial institution use S1 filings, which are publicly available as a data source, and our system could take care of fetching the data, handling the rate limits and all of that stuff, and even detecting some tables in those documents. And then they could focus on their machine learning service that could take that unstructured document and spit out more sort of identifiable entities or features for them, right? And we felt like, oh, that's a very interesting way to use it, because it's accelerating them and their roadmap and reducing their dependency on software engineering. So yeah, we do routinely come across some very interesting use cases.
Business use cases like a shipping broker, multiple e-commerce companies working with different shipping brokers. Each one of them have built their tracking systems in a slightly different way. Now, an e-commerce company to integrate with all of those is going to be a nightmare. It's probably a 5-year project. But when you have something like Nexla in there, you get Nexsets on the inside, you get Nexsets on the outside, and you can orchestrate all of this with a single API call, irrespective of who the data is coming from, who the data is going to. So things like these, we didn't originally intend that this would be used in this particular way, but when we see this, like, oh, it makes all the sense. You're able to get one Nexset on the input, another Nexset on the output. You have one API call. You're solving a business problem in a matter of days for things that would have taken you years to do.
And in your own experience of building the technology and building the business, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process of creating this Nexla company?
We actually came into starting Nexla with a lot of data experience, but we've been surprised by some of the challenges. I'll give you a non-technical challenge that we sort of solved, and maybe Avinash can give a technical one. One of the things, as a repeat entrepreneur, we wanted to make sure that we build a product that works. We build a product that actually solves a business problem that people are willing to use and pay for, and do that in a very efficient way, right? So we ended up creating a company which started with a seed round of funding and then became profitable on that seed round of funding before going on to take further sort of money. But we wanted to make sure that you're not in this sort of cycle of keep raising more money and hope at some point we'll find the right use case. So that was a big challenge for us, getting done in practice, while in theory it sounds great.
The other technical challenge is when you start a company, you want to build it on the most latest and the greatest technology that's out there. right? So when we are thinking about this, we're like, okay, let's pull out Kubernetes, let's do Spark, Kafka, whatever is out there. And then you talk to the first 5 customers and they're like, oh, we use a AS400. Now have a AS400, or we have this thing on the ZOS. So just sort of marrying those two worlds, like, yes, we are using the latest cutting edge stuff, but it needs to work with the technology that people have built in the last 50 years. Is itself a challenge. And imagine getting a Nexset from an AS400. How does that look like, right? So I think that aspect of it, something that we did not start with, but we saw that the platform can be used for all these cases as well.
Well, that happened with our initial thinking about everything should be streaming in real time, right? I mean, you're like, oh, why not? Like everybody would want streaming in real time. That's great. But you go down to the companies, they're like, no, I don't need streaming or real time for most of my data. It's fine. So, you can do everything in that way, but how do you still keep it compute efficient, cost efficient, and everything, right? So, yeah, sometimes it's good to start with the latest tech and try to be ahead of the market, but you got to meet it at the right spot.
So how much RPG code did you have to write?
We figured it out to sort of keep it as segregated as possible. So let's say it's less than 1% of the whole thing.
I have some background working with AS400s as well, where the first job that I had in tech, I was the sysadmin, and one of the machines that I was responsible for keeping running was an AS400. So.
I was amazed at that implementation when I saw that happen. I mean, running in the cloud, peering in with an on-prem system, and that connector getting done extremely fast was like, okay, through many months of iterations on that connector architecture, we had finally gotten it right where we could connect to a completely new system with relatively little work.
And so for people who are looking to improve the overall operability of their data and streamline some of their processes, what are some of the cases where Nexla might be the wrong choice?
We would like Nexla to be the right choice whenever you are working with data, of course. We always clarify to people that, look, we're not a BI or an AI tool. Our job is to bring the data to you. There are many aspects of it, right? I mean, data is a very broad space, okay? For example, as I mentioned, we do monitor the data, as we're sitting in the flow. We're not going to say that we're going to solve all your data monitoring challenges. What we do best is we generate so many signals that you can consume in your Datadog or your favorite monitoring tool and do it there. So our goal always is we don't want to reinvent anything. If something is there, we want you to connect with it. We want to power it, right? So we certainly, that part. As I mentioned, we do run SaaS, but also offer like on-prem options. So if you're running on-prem and you want to do this one-time data migration, I don't know if you really want to take and bring in and get the security approval to deploy a system for one-time use case. So there are definitely cases where, you have to think about, hey, is this technically the right solution? And then you have to think about business-wise, does this, make sense? But I think we cover a very broad set of use cases extremely efficiently for companies.
In terms of your plans for the near to medium term of the platform, what are some of the new capabilities that you're targeting or some of the projects that you're particularly excited to work on?
We're expanding on this concept of templates where a user, who is more technical or has some specific know-how defines something, defines the template of what is my schema, what's my validation, or what's the connector, or what's the Nexset and stuff like that. And then other people use it. So we're expanding on that. We'll be bringing in more community capabilities, like, how can you do this, share your knowledge in the company, but also outside. The concept of data exchange, which you asked about early on, that's not something that's, formally offered as a product, that we'll see that. Embedding Nexla into your own product, that's something that some companies have started to do using our APIs. They embed those capabilities into their own products, as a single button sometimes or whatever. That's another area. So yeah, and as we keep working with more enterprises and more sectors, we do see that the challenges are very similar. We have had an education company use us. They need to work with data across school districts and edtech platforms. We have seen marketing companies use us. We have seen finance, e-commerce. So we'll definitely hope that we keep scaling up our capabilities across these sectors and their unique needs.
And so are there any other aspects of the Nexla platform and the technology and the problem space that you're working in that we didn't discuss yet that you'd like to cover before we close out the show?
Yeah, I think we covered a pretty good set. There's a lot to the data challenges. I think we're taking our bite out of getting the data ready to use to the user. I think, ask us in 6 months, and I'm sure new surprises have come up and new things have been done here.
Well, for anybody who wants to get in touch and follow along with the work that you're doing, I'll have you each add your preferred contact information to the show notes. And as a final question, I would like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think that I'm super happy that people are starting to focus back on data tools. I think 3-4 years ago, people were like, "Hey, this has been a solved problem." Companies have been there in this space for 30 years, and yes, data tooling has been around for more than 30 years, right? Starting with Golden Gate and Informatica, right? So first of all, a lot of stuff happening, super exciting. The gap that we still see out there comes down to that operational scale. How will data be used in more applications and by more people? And I think I'm getting more and more interested in the people aspect of it, because that's very challenging. What Avinash said, right? Like, how do you get all this complexity in a way that people can use it? And it's a hard challenge. That's what the technology challenge usually is. That how do you take something very complex, make it easy? How do you make driving easy into a self-driving thing? Someday we'll have that as well, right? So that's certainly a big challenge. The other part that we think is missing the gap is that usually when people say it's easy to use, it comes with, it's not going to be powerful enough, right? So where we find the gap is that how can tools cover that continuum, right? Be easy to use, but still give the flexibility and the power that people can bring complex problems to that. So that's another area where I think more tooling will come, and no code, low code developer tools will probably merge together.
So there's a lot of closed tooling that's available in the data space today. You have tools to do a lot of things, but you can't sort of interact between those tools very easily. And that's something that we think having an open platform is super helpful, but also have some of these concepts that we have added with net sets and what you can do with those net sets. That makes a very powerful combination. Sort of plug it in with something where you deem it's right, but also have this base broad capabilities that you could use.
Yeah, that's actually a very important point. I think in his last company where we worked together, Avinash actually designed a common standard for ad creative so that multiple companies can come and collaborate together. Will there be a common data standard in terms of how data flows across companies? We are very close to that problem, and we think and we hope that does happen over time. Yes, open up the signals from your tools. We do that through APIs. We publish a JSON manifest of everything in Nexla. So yeah, we hope that will ultimately help the end customer use all these tools together in an efficient way.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing with Nexla. It's definitely a very interesting problem and an interesting solution that you're working on. Definitely appreciate all the time and energy you're putting into helping to make data operations and just data management more accessible to more people. So thank you for all of your time on that, and I hope you enjoy the rest of your day.
Thank you for having us here. It was really exciting to chat about this, and we'll share more adventures and stories the next time we reconnect.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.